Right, this section is on the law of sines and the ambiguous case. So first, a definition. An oblique triangle is a triangle where none of the angles is a right angle. And here we have several examples of different kinds of oblique triangles. The first one is an acute triangle. And that's because all the angles are acute or they measure less than 90 degrees. The second example, example B, is of an obtuse triangle. And that's where the triangle has one obtuse angle, one angle that's greater than 90 degrees, and then the other two would have to be acute. And then the last example here just shows some arbitrary triangle and basically how we label it. So the angles we usually represent with capital letters A, B, and C, and then the side that corresponds opposite each of the angles is represented with a lowercase letter. So notice here's angle A, capital A, and then the side opposite that is lowercase a. Here's capital angle B, the side opposite is lowercase b. Here's capital C for the third angle, and then the side opposite is lowercase c. Now, when you solve an oblique triangle, if you're asked to solve the triangle in the directions of a problem, what that means is you need to find all the lengths of the sides and all the measurements of the angle. So usually you'll be given some information about the triangle and it's going to be your job to figure out the rest. Now, there's basically 4 cases of different pieces of information and scenarios you can be in when you're solving a triangle. So case 1 is that one side and 2 angles are known. So you're going to be given the length of one of the side and 2 angles. That's ASA or SAA, depending on the order of the angles that they give them to you. Case 2 are when you have 2 sides and the angle opposite one of them is known. This is the ambiguous case. It's ambiguous because in case 2, you have 3 possible scenarios. Either you have one triangle, 2 possible triangles, or no triangle at all. And we'll explain how to figure that out in a minute. Case 3, they give you 2 sides and the include angle are known, so side, angle, side. That's different than the case above because for case 2, you're given 2 sides in a row and 1 angle. For case 3, you're given, let's just draw something, like you would be given this side, and the angle between them. That's different than case 2 because in case 2 you have 2 sides and then the angle opposite one of them. And then case 4 is that all 3 sides are known, side, 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 but no angles. Okay? So if you're in case 1 or 2, we use the law of sines. If you're in case 3 or 4, then we use the law of cosines, which we'll cover in the next section. So first, what is the law of sines and how do we use it? So for a triangle with sides ABC, and opposite angles ABC respectively, the following holds. Sine of A over the side A, lowercase a, is equal to sine of B over B, which is equal to sine of C over C. So basically the ratio of sine of the angle over its opposite side is consistent throughout the triangle. And since these ratios are all equal to each other, their reciprocals will also be equal. So also you could set it up as A over sine A equals B over sine B, it doesn't matter, equals C over sine C. And depending on what quantity I'm solving for, I like to sometimes flip it around, depending, okay? So know that you can interchange it as long as sine is on the same side of the fraction. Okay, so let's look at some examples here. Solve the triangle. Here they tell me angle A is 50 degrees, angle C is 20 degrees, and then side A is equal to 3. Okay, so let's draw a triangle out here. I have 2 angles and a side, so I'm not in the ambiguous case. So I'm just going to draw out one triangle. Oh, come back, come back. Perfect. It doesn't have to be exactly to scale, so just label it. This is A, B, C. And they told me A was 50 degrees, C was 20 degrees, and side A was equal to 3. Okay, so let's see what's missing. Well, I need angle B. I need to also determine side B. and side C. Okay. Well, I can figure out angle B very easily because all the angles in a right triangle need to add up to 180, and 50 plus 20 is 70. So angle B is going to equal 180 minus 70, which is 110 degrees. So I'll go ahead and label that in my triangle now. All right, now how am I going to find the missing sides? Well, we're going to use the law of sines. So notice I can set it up now that the ratio of B divided by the sine of 110 would equal the 3 divided by the sine of 50. So let's set that up. So B over sine 110 is equal to 3. You have to keep the sides on the same side of the fraction over sine of 50. Okay. And then from here, we're going to cross multiply. So I get B times sine of 50 equals 3 times sine 110. And that means B equals 3 sine 110 over sine of 50. Okay, and I want you to write it all out like this, and then don't substitute anything in the calculator until the last step. Okay, be careful with your calculator when you have sine 110 that it's in degrees, that you close the parentheses before you hit divided by sine of 50. And we're just going to round everything to 2 decimal places. Make sure you follow the directions in the textbook or on an exam as far as rounding. And this comes out to 3.68. So here, B is 3.68. So that's done. Now, how would I go find C? Well, I would just use the law of sines again, okay? But for C, notice if I'm missing this side, then I need to have sine of 20 degrees, okay? And then it's up to us. We know what B is, so we could use sine of 110 over B. But because B, we had to round it a little bit, it's safer if we use the given information and just stick with A, okay? And that's good practice, generally speaking. So now let's find C. So C over sine of 20 is equal to 3 over sine of 50. Okay, and then that means C times sine of 50 equals 3 times sine of 20. So C equals 3 sine 20 over sine of 50. And this comes out to 1.34. So now we've solved the triangle. We found all the missing sides and angles. This is 1.34. And we can box our answer. All right. Looks good. All right, next example. Here they gave me, again, 2 angles and a side. Okay, so we don't have the ambiguous case. I'm going to go ahead and draw a triangle. And just label it. So I'll call this A, B, C. The picture, the triangle that you draw is really just to help you organize the information and set the ratios up correctly using the law of sines, so it doesn't have to be perfectly to scale. Okay, let's see. They told me B was 10 degrees, C is 100 degrees, and then side B is equal to 2. Okay, so let's see. What are we missing? So I'm missing side A, I'm missing side C, as well as angle A. All right, well, angle A I can find quickly. Angle A is going to be 180 minus the other 2 angles, which are 110 degrees, so that's 70 degrees. So angle A is 70 degrees, and then I also need to find side A and side C. All right, so to get started, let's put a little boundary here so everything stays nice and neat. Let's use the law of sines. I know this is 70 degrees, so I can find side A. I like to put what I'm trying to solve for in the numerator. It's easier to cross multiply and solve that way. So if I need side A, I'm going to put that in the top. And then I'm going to have sine of 70 in the opposite side. This equals, and then they gave me this side, so that's what I'm going to use, 2 over sine of 10 degrees. All right, and then now to solve for a, look how easy it is. I just need to basically multiply both sides by sine 70, right? You don't even need to full on cross multiply. Just multiply by sine 70. Faster than what I did last time. This is going to cancel. And now I have a equals 2 sine 70 over sine 10. And then you're going to punch that in your calculator. And this comes out to 10.82. So side A is 10.82. And they didn't give us units, so that's okay. All right, that part's done. Now I need side C. Okay. Okay, just does not want to be boxed today. That's fine. So we have C over sine of 100 equals 2 over sine of 10, right? Don't use the rounded value that you got. Stick with whatever information they gave you. So now I can just multiply both sides by sine of 100. So C equals 2 times sine of 100 over sine of 10. And please make sure you can get this correct in your calculator, which is 11.34. So for C, we get 11.34. And there's our final answer. Now, one thing you can do to check to make sure everything's making sense, I'm going to fill in the values right here on the triangle. So A was 10.82 and C was 11.34. Now, whenever you're working with a triangle, the largest side should be opposite the largest angle, the smallest side opposite the smallest angle. So see if that checks out. So notice here, like 2, that's the smallest side, and 10 is the smallest angle, 10 degrees. 100 is the largest angle, 11.34 was the largest side. So everything's checking out. It looks like we set everything up correctly, and you can do that to help yourself out. All right, last example like this. B is 20 degrees, C is 70 degrees, and A is 1. Notice they didn't give me angle A, and these two add up to 90, which means angle A must be 90. So I actually have a right triangle. So I'm going to draw a right triangle. Now, am I allowed to use the law of sine still in a right triangle? Absolutely. So here's ABC. B is 20 degrees, C is 70 degrees, and side A is 1. So what am I missing? I need side C and side B. Okay, so I already know A is 90 degrees. I just need C and B. So you could use sine and cosine in a different way, but we're just going to stick with the law of sines here. So let's solve for side C. So C over sine of 70 is equal to 1 over sine of 90. And that means C is equal to sine of 70 over, well, what's sine of 90? Sine of 90 degrees, that's the same as sine of pi over 2, that's 1. So this is just equal to sine of 70, which is 0.94. So C is 0.94. And then what about B? Well, B over sine of 20 is equal to, again, 1 over sine of 90. And that's equal to 1. So that means B equals sine 20, which is 0.34. All right. Let's do a nice box for this one. Okay, so moving on, these were all case 1, when you have 2 angles and 1 side. But what about if you're in a different scenario? What if you're in case 2? So solving the ambiguous case. Side angle. So this is case 2 in the notes, ambiguous case. Okay. So the very first thing when you're working with the ambiguous case, they basically give you two sides, A, B, and the angle opposite one of the sides. What you need to do when you start is find H. H is equal to B times sine of A. Now the letters may change. They may call this angle C. In that case, H would be whatever this side is times sine of that angle, C. So just adapt, okay? Draw this triangle in the same direction and then you won't get so messed up. What you need to do is once you find H, determine which scenario you're in. So if H, the height here, is larger than the side A that you're given, then there's no triangle, right? So if H is bigger than A, then there's no triangle because the side A isn't long enough to connect. So this is one possibility. No triangle. That's actually the easiest, then you have nothing to do. All right, if H is equal to A, then you have one triangle. Also, if H is smaller than A, but it's larger than the other side given, you still have only one triangle. So you are able to make a triangle and there's only one. Okay, and then the last possibility is H is less than A, but A is less than B. So the other side is even longer. What that means is you have a possibility for two triangles. And you don't know which scenario you're in, so you're going to solve for both. And notice the whole reason is that if the side A is less than B, it could either have an acute triangle here, or that side A could swing in, and your other triangle would have an obtuse angle here. So either you're in this scenario, and this would be your angle B, we'll call it B1, or you're in this scenario and you would have angle B2. So you're going to solve for both possibilities. Okay? As long as you're systematic and you draw a nice triangle, it won't be too crazy. So just follow the process demonstrated in the examples and you should be okay. All right, let's look at some examples. So two sides and an angle are given. Determine whether the given information results in one triangle, two triangles, or no triangle at all, and then solve any resulting triangles. So they've given us two sides and an angle. So I'm gonna set it up the following way. Draw one of the sides and the other side, and then put the angle that they gave you here. Okay, so this is angle A, which is 70 degrees. The side opposite is lowercase a. I don't know how exactly that's going to fit into things. And then this is side B, which is 7. Always set it up this way. The first thing you need to do is find H. Okay, so H is going to equal B times sine of A. Remember, this is a right triangle that I've drawn here. And sine of 70 equals H over 7. So that's where we get that H equals 7 sine 70. Okay, so in this case, it's 7 times sine of 70, which is 6.58. So H is 6.58. Now, how long is side A? Side A is just 3, and H is bigger than A. So what does that mean for us? Well, think about it. This is 6.58, and side A is only 3. I don't know, maybe it's something like this. Can I close? Is it long enough to make a triangle? No way. So if H is larger than that side, we have no triangle. And then you're done. All right, now say you didn't notice. you'd still be okay. So if you tried to set up with the law of sines, then you'd have sine of 70, sine of A, over side A, which is 3, equals sine of B over 7. And then trying to solve from there, you'd get sine of B equals 7 sine 70 over 3, which is 2.193. And then if you try to figure out what B is in the calculator, and you take sine inverse of 2.193, we know this isn't possible because sine is never larger than 1, so this doesn't exist. You would get an error in the calculator. But save yourself the headache of even doing all that work and just solve for h, and you'll know right away. All right, nice. Let's move on to some more examples now. Example B. Angle A is 32.32 degrees, side C is 574.3, and then side A is 263.6. So let's draw our triangle. Oh no, that's not it at all. And here's this side. Okay, so they gave me angle A, which is 32.32 degrees. And they gave me side C, which is 574.3. I'm not going to include side A in the picture. First thing I want to do is find H. So H equals that side, 574.3, times sine of 32.32 degrees. And if you punch this all in the calculator, you get 307.05. Well, how big was A? How big was that side? A was 263.6, which is smaller than H. So what does that tell me? Well, yes, just like the last problem, there's no triangle. The side opposite angle A was not long enough to close all three sides and make a triangle. All right. Moving on, I know it's depressing when we don't get to make a triangle, so things will get spicier from here on out. So angle C is 73.01 degrees, side A is 17.31, and side C is 20.24. Okay, so always draw the angle, I think it's easiest on the left. Here's angle C, 73.01 degrees. I'm not going to draw side C just yet. And then this is side A, 17.31. So first things first, I'm going to find H. Okay, so H equals 17.31, that side that's next to the angle, times sine of 73.01 degrees. And this comes out to 16.55. Ooh, so that's good, because in this case, C, which is 20.24, that's bigger than H, which is great. So I know for sure I have one triangle. Do I have two? Well, I only have two triangles if this side opposite the angle is smaller than the other side that's next to the angle. So since A is greater than C, this means I only have one triangle. So I'm going to complete the drawing here. I only have one triangle. And this side here is 20.24. And this would be my angle B, and this is angle A. Okay, so if this side here is larger than this side, you only have one triangle. The only possibility for two is when it's smaller and it can swing in. Okay, so how to solve? Well, we're going to use the law of sines. So I need to find angle A, I need to find angle B, and I need to find side B. All right, always list your answers nicely in a box. So let's find angle A first. That means sine of A over 17.31 is equal to sine of 73.01 degrees over side C, which is 20.24. And this means sine of A equals 17.31 times sine of 73.01 degrees divided by 20.24. And then I don't want you to round at all. So I want you to enter everything over here in the calculator and then take sine inverse of that. Okay, make sure you're in degrees, and A should come out to be 54.88 degrees. So A is 54.88. Well, I'm pretty much ready to find B because I know all the angles have to add up to 180. So angle B is going to be 180 minus this 54.88 minus 73.01, and angle B comes out to be 52.11 degrees. That has to be the next quantity that I find, because without angle B, I can't find side B. So it's 52.11. Okay, now last step, we're going to find little b right here. So I have b over, and this time I have no choice. I have to use the 52.11 even though it's rounded. Sine of that angle equals, and in this case I will use what they gave me. So I'll use C, angle C and the side C. So we have 20.24 divided by sine of 73.01 degrees. And then from here you'll get B equals sine of 52.11 degrees times 20.24 divided by sine of 73.01 degrees, and this comes out to 16.70. All right, so this is how to solve when there is actually one triangle. All right, but I'm sure you're curious, what does it look like when there's two possible triangles? Well, that's what's coming up next. So A is 42.17 degrees, side A is 5.01, and side B is 6.12. So we're gonna pretend I didn't tell you we have two triangles here. I'm gonna draw out same way as before. So here's angle A. Here's the side not opposite that angle. So side B is going to go here, 6.12, and angle A is 42.17 degrees. So what's the first thing I do? Yes, we find H, okay? So H is 6.12 times sine of 42.17 degrees, and this comes out to 4.11. Now 4.11 is less than side A, 5.01. So that means side A is long enough to make a triangle, and also side A is less than the other side B that was given to us, 6.12. So when that happens, we have two possible triangles. So we're gonna solve both scenarios, okay? Because we don't know basically which situation we're in right now. So let's copy this diagram and get going. So the first scenario, I'm gonna draw an acute triangle, okay? And I'm gonna call this angle here B1, C1, and then side C1, and then here's the side 5.01. Okay, we don't need H in there. So we have two triangles again, remember, because this side is smaller than the side next to A. Okay, so solving from here, we're gonna find angle B1 first. So sine of B1 over 6.12 equals sine of 42.17 degrees over 5.01. And then you don't really need to show me a whole lot more work, so you can just multiply both sides by the 6.12 and then take sine inverse. So B1 is going to be sine inverse of 6.12 times sine of 42.17 over 5.01, and this comes out to 55.09 degrees. Okay, so right here we have this is 55.09 degrees for B1. And then we also need angle C1 and side C1. So angle C1 is going to be 180 minus 42.17 degrees minus 55.09 degrees, and this comes out to 82.74 degrees. And then the last thing I need to find in this triangle is side C1. So side C1 over sine of angle C1, 82.74, is equal to 5.01 over sine of 42.17. And then again, you'd multiply over by sine of 82.74 degrees, and then you're done, and you get C1 equals 7.40. So this is one possible scenario. Okay. Now what about the second triangle? What does that look like? I'll copy this picture over. And show what's going to happen here. Now in the second triangle, this side here, since it's shorter than this side, can swing in. Okay, now pretend that's the same length. Pretend this is also 5.01. And so now I have this other possible triangle here that I've outlined in that light purple color. Okay, so what does that mean for us? Well, I'll erase this so we have some room. I want this back though. Okay, so this angle here would be my new angle B, but I'm going to call it B2. And then this angle here is much smaller than my first angle C, so this is C2. And then this side is shorter than my first side C, so this is little c2. Okay, so we have three new quantities to solve for. Now, how do I find angle B2? Well, notice angle B2 is supplementary with angle B1. So I know what I can do from here to find B2 is just take 180 minus angle B1, which was 55.09 degrees, which is 124.91 degrees. And think about it this way. When you do sine inverse on your calculator, remember sine inverse, the range is limited to negative pi over 2 to pi over 2, or negative 90 to 90. So sine inverse will only give you an acute angle, something less than 90 degrees. But we know that sine is also positive over here in quadrant 3. So since we had 55.09, another angle that would have the same value of sine, I think I said quadrant 3, I meant quadrant 2, would be 180 minus 55.09 degrees. So that's how you would find the other angle. And the calculator will never give that to you because sine inverse is only defined from negative 90 to 90. Okay, so I have B2. You just have to do 180 minus whatever you got for B1. And then C2, you're just going to take 180 minus 124.91 minus angle A that they gave you, 42.17, and you get 12.92 degrees. Very small. So the only time I need to use the law of sines is at the very last step to find side C2. So little c2 over sine of 12.92 degrees equals 5.01 divided by sine of 42.17 degrees. Oh, that should be 42. And this gives us C2 equals 1.67. So there's the second possibility or second solutions for B2, C2, and side C2. All right, you have to stay very organized and methodic with these because otherwise they can get confusing for sure. So last example, angle A is 43 degrees, side A is 31 feet, and side B is 37 feet. So let's start off, let's draw a triangle. So here's angle A, 43 degrees. I'm not going to draw in side A just yet, and then side B is 37 feet. This time, since they gave me units, I'm going to put units on all my answers, okay? So I start off by finding H. Okay, so H is going to be 37 times sine of 43 degrees, which is 25.23 feet. And that is less than A, which is also less than B, which means I have two triangles. Yay! Okay, so here we go. So scenario number 1, just draw all acute angles, okay? So this is going to be B1. Here's 31 feet. And then this is angle C1, this whole thing. And this whole side here is C1. Okay, so sine of B1 over 37 equals sine of 43 degrees over 31. So that means sine of B1 equals 37 sine 43 over 31. You take sine inverse of that quantity in your calculator and you should get B1 equals 54.49 degrees. Great, so that's done. Now I find angle C1 next. So angle C1 is going to be 180 minus 43 minus the angle we just found, 54.49 degrees, which is 82.51 degrees. And then the last step, since I have angle C1, is to find side C1. So now I need to use the law of sines. So I'll have C1 over sine of 82.51 degrees equals 31 over sine of 43. And so C1 is going to equal sine of 82.51 times 31 over sine of 43 degrees, which is 45.07 feet. All right, so there's all three of those there. Now, I'm going to solve for the other scenario. Okay, so let's separate things here. I'll put a little dashed line. Okay, so the first thing I do is find angle B2, and I'm going to draw for you what the other triangle would look like. Remember, you just swing that side in. It's also 31 feet, but this would be your angle B2. This baby angle here, that's C2. And then just from here to here, that's your side C2. Okay, so to begin, you find B2. So you just do 180 minus whatever you got for B1. So minus 54.49. So this is going to be 125.51. Then again, you find angle C2. So angle C2 is going to be 180 minus the other two angles. So minus 125.51 minus 43. And this is 11.49 degrees. Usually that angle comes out small because angle B2 is going to be obtuse. So there isn't a whole lot left for that third angle. If it comes out negative, you messed up and there weren't really two triangles. Isn't that comforting? Okay, then last thing is side C2. So side C2 over sine of 11.49 degrees equals 31 over sine of 43 degrees, which means C2 is equal to 9.05 feet. Okay, and then this is a really good way to drive your teacher crazy. So what we're gonna do is list everything out in two nice columns for our final answer. So we have angle B1, 54.49 degrees. Angle C1, 82.51 degrees. And then side C1, which was 45.07 feet. Angle B2 is 125.51 degrees. Angle C2 is 11.49 degrees. And side C2 is 9.05 feet. And we are done. Let's box this with pride and always write out all your final answers together like that in a nice box. All right, that concludes the section on the law of sines and the ambiguous case. Make sure you just pay close attention to detail, stay very organized and methodic when solving these problems, and you'll be fine.